Hi students, let's look at this question here, which is on how do you apply the exponential equation in real example. So you're given the mass of m gram of radioactive substance present at time t after the first being observed is given by this formula. So this is time t days. So this is the number of days, amount of days after, right? So after 20 days, you're told this is after 20 days. Find a value of m. So basically what you need to do is actually just going to replace this expression in, right? So what you're going to do is actually just put and when t equals to 20, what we need is m equals to 28, e minus 0 0.00, count how many zeros are there, 20. Okay, so this part here, once we get this in, we are going to just use calculator to calculate. So just make sure you're able to key in calculator proficiently. It's part of the skill that you need to know. So this is negative 0.00072 times 20. Okay, so then you just press enter, and this will be 27.5996. This is 27.5996. So in other words, if you find the value of m, so this will be 27.6 grams. So it's 3SF. Alright, so that's how you do for the first part. So for the second part, you're asked to find the value of t when the mass is half of its value at t equals 0. So there are a few ways to think about it. You could think as when t equals to 0, this is the initial value, but sometimes students were unable to see that, but you could just replace it in and find the value, what would the value be. So when t equals to 0, you could just quickly do t equals to 0. This would be t equals 0, this would be m would just be 28 e to the power 0, right? Because anyway, anything multiplied with 0, maybe I'll just write this now, 28 e to the power 0. So just know that this will be 28 grams. Okay, so now the thing is 28 grams. So find the value of t when the mass is half of its initial value. So when now when given the new m is 28, half of it, so this is what we call half-life. This is 14, right? So now using the formula, m equals to 28 e minus 0.00072 t, we want to find what time, how many days would have passed by when the initial value has already been half. Okay, so this case here would just be 14, half of it, and essentially you are looking for the half-life. Okay, so half life. What we get is actually just e negative 0.00072 over t. So this is half of it. This is e 0.00072 t, and this will be ln this side. We ln both sides here. I'm going to do this slowly. For how many zeros are there? I need to make sure that the number of zeros I have is correct. So 1, 2, 3. Okay, great. So this is a negative 0.00072 t ln half. Okay, so t equals to ln half over negative 0.00072. So this is the case here. So we just put ln half negative 0.00072 in key calculator. What you get is actually just 962.7 days. Okay, so this will just be 963 days, 3SF. Just round out. Okay, so this is it. Yeah. So now state the value of m when t becomes very large. So when t becomes very large, when t goes to infinity, this is how we define t, but you could just put a very, very big value in this expression here. So what you could do is actually you just put a very, very big value, t equals to 1 million. So let me show you. This will be 28. Oh, just use the previous expression here. The t, I'm just going to put, like, let's say 1 million. Okay, I'm not sure how many zeros are there, but just very large value. You'll be 0, right? So m would tend to 0. Okay, m approaches 0, so means m approaches 0 gram. Okay, approaches 0 gram. So then after which the subsequent part is to sketch it. So this is a exponent decay curve. Initially there are number of grams, right? So this is m, this is t. Initially there's this is like that. Okay, so it looks like that. Okay, so this part here, what you need to know is actually initially there are 28 grams, and then half the life will be half of it, so it's 14 grams. This will correspond to actually they will correspond to 9663 days. Okay, so this is t, but this is m grams 0. Okay, so that's how you sketch this part here. Any question or comments, please do let us know. Keep practicing, and I'll see you in the next question.